Sometimes a single tool call is not enough. Tool composition allows an agent to call multiple tools in sequence. For example, search for a product, get price, add to cart. The LLM can decide this sequence. You can also predefine tool chains. For example, a book trip tool that calls flight, hotel, and car rental internally. This reduces the number of LLM decisions and improves reliability. Modern LLMs like GPT-4o Claude 3 support parallel tool calls. The model can output multiple tool calls in one response. This reduces latency. For example, an agent can search flights and hotels simultaneously. Your code must execute them in parallel and return all results. Not all frameworks support this, but you can implement it manually. When a tool fails, for example, API timeout, implement retries with exponential backoff. If retries fail, fall back to an alternative tool or ask the user. You can also use a circuit breaker to temporarily disable failing tools. For critical tools, monitor error rates and alert. Not all tools should be available to every user or every agent state. Implement permission checks before executing a tool. For example, only admin users can call delete user. You can attach a required permission field to the tool definition and check it at runtime. Also consider rate limiting per user to prevent abuse. Idempotent tools can be cached to reduce latency and cost. Use a cache tool based on tool name and parameters. Set a TTL. The agent should be unaware of the cache. The tool implementation handles it. This is especially useful for expensive API calls. Besides schemas for LLMs, maintain human-readable documentation for your tools. Include examples, authentication instructions, and error codes. This helps other developers understand the tools. Generate docs from the schemas automatically using tools like MKDocs or Spinex.